Hello and welcome to another week geometry. This is week 18. Last week we talked about what dilation was, and that was the whole idea of making shapes bigger and smaller by a scale factor. This week we are applying that now to similarity. And so similarity and congruence have very similar ideas and definitions. Congruent shapes were shapes that were the same size and same shape. But now similar shapes are shapes that are just the same shape, but different sizes. And so, ladies and gentlemen, similarity, I'm going to use a different color here. Boom, purple, gray color. Similarity is the same shape and different size. Now, what does that mean with some more academically rigorous vocabulary? So, what that actually means is that if it's the same shape, then the angles that make that shape are congruent. And so, the same shape means congruent angles. Almost forgot the rest of my A there. And a different size means that the sides are proportional. Because remember, scale factor, ratio, and proportionality were all synonyms. And so we have congruent angles and proportional sides. And we're going to be using this to emphasize and find missing parts in two sets of similar triangles. The last thing I want to emphasize is that this symbol right here means congruent, but similar has its own symbol as well. If you are similar, you can show that by just writing the tilde. The tilde is the little curly Q right there. If it's congruent, it has the tilde with the two lines underneath it, but similar just has the tilde. So, ladies and gentlemen, let's take a look at this with an application of finding some missing sides. So we're going to use some proportionality. All right, ladies and gentlemen, if we're solving sides, what we have here are two triangles. They're wonderfully drawn, if I say so myself. Now, I haven't labeled them yet because I want to emphasize the importance with our symbology, our notation, and the labeling. So, if our triangle here on the left is triangle A, B, C, then it's important to keep track of what is the actual correspondence between the two triangles. Because remember, correspondence just means that they match. And so, if I say that triangle ABC is similar to triangle DEF, well, what matches corresponds? A matches with D, B with E, and C with F. The actual order makes it match. And so A matches with D. Boom. B with E, and C with F. And so that's how we're going to be able to tell which angles are matching and which sides are proportional. Now, ladies and gentlemen, let's go ahead and apply some sides and identify which side we're missing that we need to solve for. So, if I say that this AB is 8, its matching side is 4, I know it's matching because of how it's labeled, AC is 12, and its matching side is X. So, ladies and gentlemen, let's solve. Last week we talked about solving by matching the image over the pre-image, finding its scale factor, and then using that to find the missing side. Ladies and gentlemen, you may notice here that there isn't a pre-image, and an image, because there is no one shape that's first. So that idea of a shape that comes first when we're talking about similarity is completely dependent on context. So when we talk about a dilation, that comes in with a story, that comes in with a situation to know if there's a shape that comes first. The strength and probably the difficulty of mathematics is that we remove context, we remove the story, so we can really focus on just the mathematical properties that are at play. And so in this diagram, what that means is you get to pick which one's the image and which one's the pre-image. You get to pick which one you want to come first, and that way you'll be able to set up your proportion so that it's convenient for you. Because of the fact that our x is in the second triangle here, I like having my variables on top. So I want to pick that x to be in the image. And then we're just matching the image over the pre-image. Because they correspond, because those sides match, we can write it out as a fraction and set up our proportion from there. And so we can have our x over 12, here in blue, because they're corresponding sides, and set that equal to the other corresponding sides, 4 and 8. Now, because I put the x on top, I'm pretending that that's my image, so the 4 has to go on top. And that's going to be going over the 8. And ladies and gentlemen, from here, we can solve. For those of you who have a more intuitive sense about proportionality, you may have already noticed what the answer was. You may have gone, wow, 4 is half of 8. So x must be half of 12 to equal 6. Excellent, brilliant, well done. Ladies and gentlemen, we're going to look at some examples later on that are not as intuitive because they have decimals or because the actual ratios are not as convenient as 1/2 as big or twice as big. And so I'm intentionally picking numbers that are easier so we can double check our answers and then make it easier to solve and follow through with. So, ladies and gentlemen, that being said, let's go ahead and solve this the way that we would know how to do using our properties, using the fact that multiplication undoes addition. We are dividing by 12 on the side with x, and so to solve for x, we want to multiply by the 12 on both sides. The 12s on the side of the x eliminate, and on the side with the 4/8, like you may have already guessed, 4 divided by 8 is 1/2. So our value of x is 1/2 times 12, which we know is 6. So our value of x is indeed equal to 6. Perfect. Let's take a look at another example. All right, ladies and gentlemen, looking at our next example here. So we have triangle ABC with 9 and 15, and we have our second triangle with x, y, and z. Ladies and gentlemen, I have not labeled our second triangle yet because how I label it changes what our answer is. Because what is important is not based on how it looks, but how it is labeled, because that is going to tell us where our correspondences are. So ladies and gentlemen, don't just rely that the diagram is always going to be drawn to scale. You can do that sometimes, especially if it's on a coordinate grid, but if it's just a generic triangle that is unmarked and unlabeled, then you really have to rely on the parts that are labeled in order to answer the question. And so, we know that A matches up with X, B with Y, and C with Z. So, I'm going to go ahead and label it, and then we'll be able to go from there. So now that I've labeled it, we can tell that A matches up with X, B with Y, and C with Z, similar to what we worked on in the last problem. And so we can solve for our missing sides because the sides are proportional. And I'm going to choose the triangle with the variable to go on top. The language that I use there is very intentional and very specific because if you chose a different fraction, as long as what corresponds is in your fraction, you're going to be just fine. And so, let me explain that another way. What fraction would work to solve this? Well, the fractions that you could use to solve this would be 9 over 27 equals 15 over x. Why? Because 9 and 15 are in the same triangle. They're both on top. 9 matches up with 27 because we can match up the letters A with B and X with Y. And same thing with 15 and X. And so this works to solve for X, and you will get the right answer solving for X using this fraction. So this is awesome. Another one that works that's slightly different than what I've described so far. So another fraction that would work here is not talking about the image over the preimage, and it's not talking about the scale factor. It's just relying on what corresponds. And so we can match sides in the same triangle together. So I could put 9 over 15. And as long as I match in the second triangle the same corresponding sides on top and on bottom, it will solve for x and it will be correct. So the 9 matches up with 27 and the 15 matches up with x. This also solves for x. Ladies and gentlemen, the one that does not solve for x, which I'll go ahead and write in red, just like red light, green light, is this fraction. 9 over x equals the 27, or no, sorry, the 15 over the 27. This does not work to solve for our variable, and here's why. Even though 9 and 15 are both in the same triangle like you see in this first example, and even though x and 27 are in the same triangle like you see in this first example, 9 and x do not match. They are not corresponding sides. 15 and 27 are also not corresponding sides. Hold on, I'll be right back. All right, I'm back, and my son is happy again. So, my preference in all of these examples is to use what we already know and have already been practicing, which is the image over the preimage, and make it easy for ourselves by picking the variable to go on top. And so my preference of all these examples I've shown you, where the greens do work and the red does not work, is to put x over the 15 and set that equal to the 27 over the 9. Because every other of these examples that work will just take more steps to solve versus the one that we've written out just right now. In order to solve this, we're just going to multiply by 15 on both sides because we're going to undo multiplication with division. And then our value of x is going to equal 27 divided by 9 times 15, which, if you work out calculator geniuses, you'll get to 45. You also could have guessed that by noticing the pattern from 9 to 27 is multiplied by 3, so 15 times 3 is x. Now, ladies and gentlemen, what if we needed to solve for angles? So let's say we're solving for sides and we're solving for angles. Well, the good news is, in order to solve for angles, you just need to know which ones correspond and then write in the number for both. So, let's say in this example, we knew that angle A was 90 degrees. Well, angles are congruent in similar shapes. So we know that A matches up with X, so X is also 90 degrees. Let's see here. Let's pick another color. Let's keep going with this. Let's see here. We haven't picked teal yet. Oh, teal's a great color. Let's go ahead and say angle B here. Oh, you know what? We don't even need to put in a number. We can just use symbols. Boom. Single tick mark. What is the other corresponding angle? Well, B matches up with Y. So boom, Y is also a single tick mark. And let's go ahead and do one last color here. Let's go ahead and pick, let's pick orange. And so C, let's go ahead and do 2 tick marks. So what other angle is going to have 2 tick marks? C matches up with Z, so by process of elimination, boom. We have all of our angles matched up. They're all going to be the same degree measures as long as they correspond, because corresponding angles are congruent and sides are proportional in similar triangles. So, ladies and gentlemen, this is where I'm going to go ahead and end this video. I'll see you guys in the next video. Thank you guys for your hard work. Don't hesitate to email me if you have any questions.